Okay, so for this first problem over here, all it's saying is to actually do the scaling out the vector to 2a. So I'm actually not even going to count these dots over here. You could feel free to, but all I actually would require my students to do is just kind of give me, hey, you know what? So vector a is that long, so I'm thinking 2a is gotta be something like that long right there. And that's the first one. So this is basically what I'm going to be doing for the rest of these problems right now. And if you want to try these out on your own, feel free to do so. Okay, so for the very next one, we have 1/2 of a. Notice it actually says a and not b. So half of a would look something like that. And this is 1/2 vector a. And for problem 3, it says -4c. Okay, so c is pointing upwards, so -4c, it's going to go downwards about 4 times as long. So this is -4c. And we have d going down into the left, and it says -1/2 d. So I'm going to be saying that it's going to go up and to the right, half that length, half that distance. And this is -1/2 d. Alright, so that's scaling our vectors. Okay, so for problem number 5, we have a little vector addition here. So we have a plus b is equal to the resultant vector r1. So we have a, which is going to the right, about that much. So this is a plus b, which is going up and to the right. And that's resultant vector r1. So that's our resultant vector, r1. Okay, and for problem number 6, it says a plus 4c. Okay, well, we have a, which is going to the right, and plus 4c. I could count these blocks and everything and make sure I'm going up 4c, but honestly, that's a little nitpicky, and I would like to think that most of your high school teachers wouldn't force you to do that, although I understand if they choose to, just because it's being a little bit more accurate if you are counting. And this is our resultant vector, r2. Okay, so for 7, we have a, and then 2b, and 1/2 c. Okay, so we have a going to the right, and 2b. This isn't exactly going to be my 2b, but we can imagine that that's 2 times as long as b. It looks a little short, but I think I'm okay with that. And then 1/2 c. Okay, and we're going to have our resultant vector, r3. So we started over here, ended up over here, and this is our resultant vector 3. All right, and coming down over here to problem number 8. Okay, so for problem number 8, we have a minus c. Okay, so our vector a looks something like this, minus c. Okay, so instead of going up, we're going to go down 2. And this is my minus c. And that gives us a resultant vector of r4. All right, so that's that one. Okay, so going on to 9, we have b minus a. And this gives us a resultant vector 5. All right, and now for 10, we have 2c minus b. And that gives us resultant vector r6. All right, and on to number 11, we have 2c minus a minus b. Okay, so we have 2c minus a minus b. and that gives us a resultant vector of R7.